There we go, we're recording. So for this one right here, I want to use Newton's method to approximate the root of the equation. And by root here, they mean intersection. So I want to identify that intersection x value. And so looking here, I would guess it's like 1.8, 1.9-ish, somewhere in there would be a good first guess. And then here, I have to convert that to a single function, not two functions set equal.
Yeah.
So here's the way I would set that up, and then I'll show how I would do it on a spreadsheet. So order doesn't really matter. I'm guessing that that happens at about, I'm going to call it 1.8. So that's going to be my initial guess. And then for my function, I want to subtract one of these. So I'm going to choose to subtract this guy over that way. So my f of x here is going to be the cosine of x squared over 3 minus x over 4.25. And then my f prime for that, since this is more than just an x here, I'm going to have to use the chain rule on that part. So derivative of cosine is negative sine. Leave the inside alone at first. And then I have to multiply by the derivative of the inside, which would be 2x over 3. And then subtracting, the derivative of x is just 1, and it stays divided by that. So that's just going to be 1 over 4.25. So then my Newton's method formula is always x minus f over f prime. And sometimes it's worth simplifying, sometimes not. This time I think not. So this will be x minus big fraction cosine of x squared over 3 minus x over 4.25 divided by negative sine of x cubed over 3 times 2x over 3 minus 1 over 4.25.
Wait, why is there Q1?
What's that?
Oh, yeah.
Did I make a mistake somewhere?
We want to be x cubed, be x squared.
X squared. Oh, why did I write that down? That was weird. Eraser. Thank you. Where did I get the 1 in the numerator there? Fix this. Say square. So looking back here, highlighter. But my tools are missing. Something's weird on the screen. Sec. Desktop. Can't get my highlighter. All right, it's all right. Red. When I take the derivative of x here, its derivative is 1. And then it's just stuck being divided by the 4.25. And then we looked at how to use the answer button in Desmos to do this. I'll say that again in a sec.
I just used the quotient rule and I got that. How did you just easily see that?
Oh, why did I not use the quotient rule?
I mean-
Because the denominator is constant, you don't need the quotient rule.
Okay.
Yeah, so the way to think about that is I was looking 4.25, oops, 25. You could say that's 1 over 4.25 times x. So that's just a constant multiple, it just hangs on.
I see.
Yeah, so it doesn't matter whether it's a multiple or a divisor. If it's constant, it just hangs on.
Okay.
Yeah, so I didn't have to use the quotient rule there. But the quotient rule works on it, right? Because that derivative of the denominator is 0 and it cleans stuff up pretty quick.
Yeah.
All right, so then this is what I want to enter into some bit of technology that I can recurse with. Okay, it's starting with 1.8. So here's how I would do that on a spreadsheet. Let's see, I'm going to split my screen so I can kind of see my function. Thank you, ad blocker. You can see that right there. All right. So here, really all I need to do is start with my guess. So my guess is 1.8. So I would just type that in. And then below is where I type the formula. And I do that by just clicking on the cell above. So my formula is equals X, there's my X value, minus, to do a fraction in a spreadsheet, you got to use parentheses / parentheses for the numerator and denominator, if you're going to use a spreadsheet. And then in the first parentheses, I click back there and I type my original function where X is that number above. So I would do cosine, parentheses, and then I would take the number above raised to the second power, and then divide that by 3. And then I need to close the cosine and then subtract the number above my X value divided by 4.25. Oops. 4.5. And then my denominator goes in here, and that was the negative sign of my X value raised to the second power divided by 3. Close the sign. You got to be explicit about multiplication on a spreadsheet, so you have to use the asterisk. And then that was what, 2x? So 2 times the number above over 3. And then minus 1 over 4.25. And I'm pretty sure I typed it correctly. And if I did type it correctly, I can then just fill that down with the bottom right corner. And then it's like using that previous answer button in Desmos, which I'll demo next. So sometimes I like using a spreadsheet for Newton's method, similar to using the previous answer button in Desmos. So a reminder about how Desmos works. In Desmos, I would type my guess, 1.28, hit enter. So now it is the previous answer, ANS. And then for my next line, it's previous answer, my X value, minus, set up a fraction, and then use the previous answer instead of X. So I would have the cosine of the answer squared divided by 3, close the cosine, minus, oops, the previous answer over 4.25. And then down here, I have negative sign of the X value, the previous answer, squared, 3, close that, multiply by twice the previous answer. Times isn't necessary in Desmos. It'll guess that you want to multiply. Divide that by 3. Nope, not. Oh yeah, I guess that's okay. And then over here, I want to subtract 1 over 4.25. 5. Oh, that's a different answer than I got before. I must have typed something wrong.
Four, but not even close. I think 1.8 is closer than 4.
Yeah, I typed something wrong here. I'm trying to see what I typed wrong. All right, so the original function is, oh, haha, radian mode. I got to be in radian mode. You can't do calculus in degree mode. Yeah. Okay. I was thinking that when I first started. I got to remember to switch to radian mode. All right. And once I do that, I hit enter and then enter again and again, and it'll start doing the same thing. All right. And they said repeat that till you have 5 decimal places stabilized. So it looks like, do I have that here? Yeah, looks like it. So my 5th decimal place would be a 1. I think I would probably round that.
It's crazy how accurate it is.
3631. Yeah, it's accurate pretty quick,
Yeah.
but it doesn't work all the time, right? We saw some examples earlier where it diverged. But it works most of the time, which is pretty slick. Yeah.
I got lost, that should be fine, like the first answer with our